and we have now to listen to our first presentation. It's come from Spain and has a question: should I move to 4D scanner or not? Beatriz, please, you have the word.
Of course you should, but let's wait until the end of the session, okay? Yeah, my presentation is going to be what I'm going to try to show you the capabilities of a 4D scanning system, and in particular those offered by Move4D, which is our technology. I hope at the end of the session you can get a more informed decision if you want to acquire a 3D scanner to change from 3D to 4D scanning, or even if you want to buy a 4D scanner directly. So 3 topics I'm going to cover. An introduction that I promise is going to be very, very quick about the company. Key features that make Move4D different to other 4D scanning solutions, and a sneak peek of ongoing developments, okay? Because we are updating and upgrading the system all the time. So let's go for the introduction. Move4D is a product that belongs to IBV, the Institute of Biomechanics in Valencia. We are a not-for-profit R&D organization. We make consultancy services, R&D for companies, but also technology transfer in different fields: sports, apparel, wearables, whatever, covering biomechanics, anthropometry, human factors, ergonomics, and so on. We study everything about the human being and its interaction with the products and environments, okay? And we are about 170 people. Move4D comes from the anthropometry research area. Just a little bit of history, okay? We started in digital anthropometry in 2004. From 2004, when we acquired 3D scanner, foot scanner, and body scanners. From 2004 to 2012, we gathered a lot of data, males, females, children, because we also conducted a big survey in Spain. At that time, 3D scanners were not the same as right now. So there was a lot of, we had to edit the 3D content. So we just could extract measurements. So we started developing tools to get the most of these 3D scans. At the end, in 2015, we launched technology that is able to capture the foot shape with 3 pictures, and same for the body with 2 pictures, 1 lateral and 1 frontal. In 2019, we launched here at 3D Body Tech in November, before pandemic. We launched our Move4D, which was 1 step ahead. So I showed that slide before, but what is 4D scanning? 4D scanning is what you see. It is a technology that is able to capture the human body shape, the outer surface of the body in motion. With Move4D, what you have, not only you've got the process, the rig mesh, automatic rig mesh, but also the measurements, and also at the end you can compute any variable that is from the surface of the body. So let's go through the key features. What are the key features that make Move4D different to other 4D scanning solutions? So I will say 4. I will point out 4. Okay. The first one are the technical specifications, the optimal compromise of tech specs. Why do I say that? Because we are users of Move4D. So we decided to develop it because no other commercial brands were suitable for our research needs. So for us, it was really critical to have a very quick, fast scanner and with a large scanning volume. And that's what we have right now. The largest and the fastest and the largest scanning system. Second, I will say that it's modular and scalable. This is our Move4D module, which is the basis, okay? Actually, it is quite flexible because it is configurable, because you can have different optics, you can change distances, you can change orientation as well. From that module, we configure, which is our base product, which is the 12-module configuration, which has a scanning space of 2 by 2 by 3. Very quick, right after we launched the 12-module configuration, we had the need to enlarge the scanning volume. And now we have also another product that is 16-module configuration that covers a scanning space of 2 by 3 by 3, okay? And let me introduce this other, let's say, proto, because it is not a product, but that we had to configure as well, because we had a need to scan very precise different postures in a static and sitting posture. And another thing is that it has to be portable. Let's say we have to deploy it from one location to another location. So that's the design, and that's the one that we are using right now. It is a prototype, and we are thinking about making a product out of there. What do we do with this prototype? For example, we are making a huge anthropometric study on children right now. Right now, we are at a 50% progress, more or less. We are scanning. We are scanning about 1,200 children out of 1,500. Okay, so we are gathering anthropometric data and strengths of all those children from 4 to 15 years. Different postures, those that are scanned, and we are extracting 127 measurements. This is an anthropometric study that we are conducting at IBV, going from one location to another location to get the scans from the children on request by the committee, the European Standard Committee. The objective of this survey, it is filling the data gap existing of children data, as the one that from last time, I think it was from 2000, and producing new guidelines of anthropometric data for product design. Why this is suitable for large anthropometric studies? Because it is very accurate for different postures. Texture, you can get the texture, just in case you need skin annotations as well. It's very suitable. It is portable and easy to deploy. Also very easy to calibrate, very easy to use because everything is automatic. Easy to anonymize data sets. We are talking about personal data, so you can anonymize from our homologous mesh, either partially or totally as well, the personal data. And everything is being processed in local, so that means that you don't have to share anything with third parties. At the end, it is very versatile because right now you use it for a survey, but in the future, most of us are R&D centers, so why not to use it for another project that 4D scanning is needed? So third feature that I will say that makes us a little bit different is the outcome, automated data outcome ready to use. Why? Because I said we have an automatic processing software, fully automated, non-dependent on user skills, directly produce the usable data, no third-party softwares, and run locally in our lab. So I will stop a little bit in this slide, because this is our user interface. On the left-hand side, you can see the point cloud with more than 4 million points. On the right-hand side, you have the mesh, the process mesh, with our template fitting algorithms that are incorporated into the Move4D software. That means that this template, that is actually rigged, it has consistent topology, what we call homologous model. That means that there's point-to-point correspondence along the sequence and among the subjects. It is completely rigged. It has 63 skeleton, and also it comes with UV maps. Those UV maps also have pixel-to-pixel correspondence as well. Something that I want to point out, and it is very important, this is an actual 3D scan, okay? This is not a model. This is fitted with our template mesh, but it is a 3D scan. As we come from anthropometry, also the software comes with measurements. In a static pose, more than 100 measurements and automatic complying ASTM standards and ISO standards, but also dynamic measurements. This is a little bit more challenging, okay? Because there's no definition about dynamic measurements. So sometimes to extrapolate static into dynamics, it's not trivial. But at the end, we already have 19 body measurements in dynamic implemented into our software. This is just an example that are related to dynamic measurements. We just presented in SMAC in Athens last month. A paper is here on the bottom, so if you want to have more information. But at the end, it is for biomechanics, and what we are asking, it is like a new paradigm, okay? Can 4D scan provide more information related to dynamics of tissue behavior to improve clinical understanding in gait motion analysis? In this case, it was related to neurological disorders, okay? So we made a test, and the tests were very good because at the end, we saw some correlation between the dynamic measurement to the muscle activation. But still, we are at the very beginning, and it is needed further research, okay? The automated data, the outcome, also can be, the system also can be synchronized. This is very important for our research because sometimes different human factors, computer vision, you need to have information from different systems. So those are just examples, like RGB cameras and mock-up systems that can be synchronized with Move4D. This is one example of a setting of synchronized, a set of 4 calibrated RGB cameras with Move4D made at IBV. This type of setting is ideal to generate ground truth datasets for machine learning. Also, the labeling is completely automated, okay? So you can label, like, for example, anything that is on the surface, like cementation, vertex, body parts, wherever. And what it is very important, that this labeling is very, very precise, because you know that right now, the labeling is being made by non-expert clicking on joints on the images, and this is fully automated. 2 projects that we are running in this field at IBV. Extending existing deep learning models, like, for example, MediaPipe from Google, with additional joints, so increasing precision. And another one is learning new deep learning models that are more efficient and robust in providing the information from the shape, pose parameters of a human model. I'm not an expert in computer vision, so if you want to know a little bit more about that, I would be pleased to address you to the right people at IBV, okay? But I just wanted to show you what we are doing. Another thing that I think it is important and makes Move quite unique is that we can export in different containers, file formats, depending on the data that you want to get. So you can get the data related to the measurements in a CSV, but also OBJ measures, TRC, the trajectories, FBX, the rig mesh. So you've got plenty of formats to be integrated into the different softwares, okay? This is, sometimes it's a little bit difficult for us to test and validate because we don't have access to all those softwares, but we work very close with customers that they help us to make it possible as well. So this is just an example of something completely exported, automatically exported from our Move4D in FBX, and then imported into Blender. This is the same render, but with two different points of view. And some examples are projects with companies that are willing to have different formats, file exchange formats. This is with Forvia, from the automotive industry. They were willing to have real body mannequins in different percentiles for human factors in car seating, and they need it in FBX and in IGX to use it in environments like Blender or Katia. So that was in a static pose. They needed it rigged because they have to move a little bit the pose. But who knows? I mean, in the future, they will be interested in dynamic as well. This is another example from Decathlon. We generated a large data set combining diversity in body shapes. Actually, Alejandra Polanco is going to make a presentation about the use of this data, but so I invite you to go and see her presentation. But just for you to know that we are handling about 10 terabytes of human body surfaces, so that's quite a lot. And the last fourth key feature that I think it makes us different, it is about people. Because who we are, our knowledge, what we do, we are IBV and we are users. And we need to have the last updated product and upgraded product to be able to conduct our own research. So that makes, for example, we have 3 labs. We are using these labs. We have one lab used by our human factors and anthropometry, another one from biomechanics, another one that is the one that I mentioned before that we call Proto Lab, that is portable. But it is not just like that, okay? Once we are working on delivery and everything. Before we make my colleague Daniel, he makes a project for the customer because depending on the configuration and everything, installation could be different optics, can be mounted on the walls, can be mounted in trusses, etc. Yeah, I'll go quick. But so each Move4D lab is unique, okay? So there's an on-site deployment, on-site training, also remote support along the year, and at the end, remote training with our IBV researchers, which is, I believe it is very important because they can share interest and uses of Move4D. We are not just IBV, we've got partners like Human Solutions of North America and 0Z7 in Japan. I believe Matt is around here from Human Solutions. We have 10 labs already deployed all over the world. One in a large company in the US and I think 4 in research centers, Belgium, Germany, US, Canada, Japan as well. The 3 that I showed you as well. So at the end we have 10 labs in those 2 years. And I'm going very, very quick as far as I know, but just to give you a sneak peek about the ongoing developments that I think it is very important. We are working in user-defined measurements, so the user creating a user interface so the user can define their own measurements, but not only that, those measurements that could be editable, okay? The third The third development we are working on is about the topologies for entertainment industry. They don't work well with our dense mesh, so they need a lightweight mesh, not on the face, but on the body. So we are working with an institute, Video Games Institute, the first one in Spain, ranked in Spain, and I think it is the seventh in the world. Okay, and the last ongoing development is the automatic object removal. As you can see here on the screen, we are working different strategies to remove the objects from the scene, from the capture, to be able to process the scan and then get the homologous model. So, well, I know it is an investment. It's quite an investment to buy those kind of technologies, but I hope if you've seen that those key features could be critical for you for your own research, I will say, yeah, move to Move 4D. We will be here the 2 days, so pleased to meet you along the 2 days. Thank you very much.
Thank you very much. So we have 2 minutes for questions. Any questions? Online, we have currently no question, but from the 11 online people, if you listen me, you can write your questions in the chat. Definitely the first question is coming from
Christian. So I'll jump straight into technical. What about loose clothing? Scanning loose clothing or just not having a tight clothing?
We can scan loose clothing. Yeah, of course. I mean, this is a...
I think that microphone is not on currently.
Hello? Yeah.
Yes.
Yeah, of course. I mean, this is a 4D scanning, can scan anything that you want. You can scan an object, you can scan in loose clothes. The only thing is that the homologous model, the consistent topology, point-to-point correspondence, to be able to track, you just get it once the clothes are tied. So the accurate position it is if it is tight clothing. But we've got some examples of loose clothes that you can see that they are quite on the booth, that they are quite good as well, even if they are not homologous mesh.
Thank you.
Over there is question. Yeah.
You talked about an investment, and I guess I would like to know how much it is, or like for the smallest system.
There's no smaller system. the prototype has the same configuration, 12 module configuration than the one that I showed before. So we've got 12 module and 16 module. The proto doesn't have even a price because it is not a product. But of course, I mean, I can give you more information in the booth about pricing. But of course, it is a completely different product than a 3D scanner. So it has more capabilities to do it. So let's say that it is for research.
So, yes, the next question.
Just one quick question about your portable system. What would be the time of setting it up, and yeah, how many people would be required, and yeah, all that?
1 day.
Okay.
1 day to set it up. I mean, if we see that there's some interest from the market, and we decide to launch this product as a product, then we will try to optimize even the structure, the things, to take the most of the time as well. So, but right now it is 1 day to set it up, and space, I think it is 5 meters. The one that we have, it is 5.5 meters. Yes, yeah, that's something that we work very close with the customer to optimize depending on the space that they have.
Okay, the very last question before the next presentation. You can write down your questions and ask Beatriz after that, but we have to try to keep in the time. I think, Chris, you can already switch your computer there in order to save the time, so please.
Do you have any encryption for security and privacy?
Encryption for security and privacy.
That might be an answer. I mean, we are going to work also in the panel about the security data as well, and tomorrow. So that will be an answer about it. We have ISO 20. We comply ISO 27000, which I believe, because I'm not really the person, but talks about the personal data as well. But to be honest, to give you a proper answer, maybe tomorrow, or I'll talk to my people to see what's the real answer. But I believe it is not encrypted. It is encrypted. I mean, we work in local, so I believe it is not encrypted.
I can answer, but in the break. So principally, if you work locally, you have the data there. It doesn't have to be encrypted. If you go in a network, then it's a different issue, but this is your laboratory. And what to do the data after that is okay. So thank you very much, Beatriz. I believe there are many other questions. I have at least 5 in my list, but we will talk about it further.